This is interim presentation for DfM from Team 6, analysis and redesign of an agricultural shredder machine. An agricultural shredder machine is a mechanized device designed to reduce the size of agricultural waste crop residues and organic materials into smaller, manageable pieces. The primary customers are the small and medium scale farmers who process crop residues like maize stalks, paddy straw, and sugarcane leaves. Our secondary customers are municipal solid waste handlers who provide continuous urban waste management. Annual estimated demand is 650,000. Estimated production volume is 1,670,000. Task function of agriculture shredder is to shred waste. First primal basic function is to reduce material by using sharp blades to cut the agricultural residues and crush the hard materials and tear or pull apart flexible or fibrous materials into smaller pieces by shear forces. Another basic function is to collect material by convey or transport shredded waste from the cutting chamber to the discharge point and contain in hopper or output module until discharge. Assure dependability means to protect mechanisms like overload protection and maintain stability by using a wide base frame. Convenient to farmers, easy to access the hoppers and accelerate the operation without delay. Offers enhanced to the product, able to adjust settings of blade configuration and rotor. Facilitate cleaning, easy to remove residues, prevent clogging, and ensure hygiene and smooth operation. Please sensors but reduce noise of motor, vibration damping, which is safe for the ears, and reduce dust, which comforts the user.
As per the assembly sequence diagram of the agricultural shredder, sequence 1 shows the bottom-up assembly approach where the base frame acts like a primary jig and the other components are assembled over it. On the other hand, sequence 2 uses parallel assembly of 3 bench tested modules, then mates them to the base frame base plate, versus sequence 1 which builds inside the housing. This cuts handling, improves access and alignment, moves faults earlier, and enables parallel work at separate stations. Using the 5 criteria to determine which assembly sequence is better, sequence 2 scores higher. Overall, biggest gains are in handling, joining, and testing, with an added benefit of true parallel assembly for the 3 modules. The function component matrix shows how the components directly perform the function as per the fast diagram. We can see all the components are mapped to their respective function. It performs and none of it is unmapped. For this matrix, the most covered function is maintain stability and the least covered function is adjust setting. On the component side, the box housing and motor shaft is the most multifunctional. At the other end, the keys and bush are the least multifunctional.
Materials including the primary and important components of the initial product. Bill of materials of product which helps in estimation of total product cost per unit. This bill gives the idea of material manufacturing processes and assembly processes required for each part in the product. Further, it expands in the cost for manufacturing, assembly, and material, which help in calculating our total cost per product, which is $550.27. Different segments, making them qualified for most problematic or rather simpler. Here you can understand the same situation where you have a look at the fourth quadrant involving high importance and high cost products. In our case, it's base frame and motor.
On this slide, we would look at the product family design. By observing the functions on the fast diagram for our primary and secondary customer groups, 5 functions needed to be different. These were protect mechanism, reduce noise, reduce dust, contain material, and ease access. These differentiations arose due to the types of material being shredded and the acceptable risk and reliability levels. The unique models that relate to these functions were the base frame, feed hopper, output module. These modules are able to increase the reliability, safety, and ease of use of the shredder machine. On this slide, we see the physical differences between the primary and secondary design. For the feed hopper, the added flap prevents accidental contact and contamination. With the output module, we see an open versus a closed box design. The latter was done for increased safety. Next, we see casters added to the base frame for the secondary design for ease of use. Finally, protective cover is placed on the belt and pulley for added safety. Overall, this modular interface strategy enhances manufacturability and enables faster product switching, which is valuable for mass production and future product updates.
First approach assembles components in situ within the housing using sequential installation. Early integration of variant-specific components complicates setup, misaligns datums, and increases cycle time. The second approach uses parallel assembly of rotor, drive, and housing modules, boosting labor efficiency. Delaying variant integration until the housing phase simplifies core production, reduces setup errors, and enables flexible customization. For secondary customers like municipal waste handlers, the empty protection box and caster wheels are added to the housing at later stage, enhancing safety and mobility without disrupting the primary assembly for farmers. Our design and sequence has various benefits. Parallel assembly speeds up manufacturing for faster production, streamlined processes reduce expenses, and modular parts simplifies repairs, making maintenance easier for farmers and municipal users. These benefits enhances efficiency and usability. Thank you.